Hello, this is Kurosh, and today I'm going to explain the things that we did in lab exercise 9. So basically, the thing we need to do is just improving our physics engine script and adding some variables in physics object. So I'm going to start with physics object. I'm going to show the variables that we needed to add in physics object. Basically, here we have a gripness for the physics object, and we're going to use it a lot. We added net force for the spheres, and we already put them to 0, and we're going to change them throughout the physics engine. So inside the physics engine, as you can see here, in the fixed update, we just changed the fixed update, and inside the fixed update we are calling two methods after getting the object color by white. So in fixed update, which is like it's gonna update in every frames, we have a collision update. I'm gonna go through the collision update first. Inside the collision update, we are basically going through the objects that we have, and if they're like together same, we just continue. This is like just making sure that they're not same. Then we have a struct here, which is collision info, because we need to make a data type which will let us to use to return boolean and vector at the same time. So inside our collision info, we have did collide normal, and we have the constructor for them, and we are just pointing at them because we need to use them in our collision update. So in collision update, we first instantiate the collision info from collision info struct, and we get the constructors. In here, instead of overlapping, everything will be collision info. So everything here in if statements are same, just overlapping will be collision info, and not overlap will be collision info dot did collide, because not overlap was like not colliding. And in here we have still the same things, but in here we have a new variable called force gravity, and this force gravity is like get gravity force by object A, and we have a gravity dot normal, which is the dot product of the force gravity and collision dot normal. In here we have gravity projectile normal as well, which is the multiplication of collision normal and gravity normal as well. We have a Fn, which is normal force, which is equal to minus gravity projectile number, and then we have a draw ray of color green. And in here we have two object.net forces for A and B. For the first one is plus, and for the second one is minus, because they need to neutral each other. And in here we added a lot of stuff. We added a vector 3 value relative to A, and object A minus object B velocity. We're just going to calculate the velocity of them, the difference between velocity. And we have a float here. That float is going to give us dot product of the vector of well to A and collision info dot normal. And in here we have a projectile dot normal, which is still collision info dot normal times well dot normal that we instantiate here. And in here we have a projectile to the planes, which is equal to the relative to A and minus to normal. And in here we're just going to calculate square magnitude of this variable. If it's bigger than a really small number, we're going to do this math here. So we have a coefficient of friction. We're going to calculate the friction by a multiplication of gripness and A gripness and B gripness. We're going to calculate the friction magnitude for magnitude times coefficient of the friction, which we set it here, and eventually we're gonna have F, which is like the total force, which is equal to minus this variable dot normalized times friction magnitude. And then we're gonna have a color here, which is color around like purplish or something, and we have a net force still plus and minus for A and B. And then we have a kinematic energy method, which is up here. In here we just commented this all out, and we have a get gravity of object A, and the object that net force of the thing will be plus or equal to plus equal Fg. In here, however, we added some other stuff we need. We added this color, which is purple. That color down there is more like blue, is more like a red and greenish something, but in here we have a color of purple. Anyway, this acceleration of this frame is going to be object a.networth by object.mass, and that's all in this function, and rest of the things actually are pretty much the same. Now I'm gonna go to the Unity and I'm gonna run the code, and you'll see what's gonna happen. So as you can see here, the square is just moving, but like if I rotate this plane that the square is on it, is gonna start moving. And now if I'm like if it goes to the wall, it's going to be static and it's gonna fall. That's it for lab exercise 9. Thank you.